Imagine a website with a login form, username, password, a sign-in button. Nothing fancy. Now imagine someone logs in without knowing a single password. Not by guessing, not by hacking some secret backend system. They just typed a slightly weird sentence into the username box. That's SQL injection, one of the oldest, simplest, and still most common vulnerabilities on the internet. And by the end of this video, you'll understand exactly how it works, why it's so dangerous, and how developers stop it. Let's get into it. Today, SQL injection, or SQLi. It's been OWASP, top 10 list of web vulnerabilities for over 2 decades, and it's still showing up in real breaches today. So let's understand why it refuses to die. Quick refresher before we break anything. SQL stands for Structured Query Language. It's how applications talk to databases, asking for data, inserting data, updating it, deleting it. So when you log into a website, behind the scenes, the app usually builds a query that looks something like this. The app takes whatever you type into those boxes and drops it directly into that query. If the username and password match a row in the database, you're logged in. Sounds reasonable, right? Here's the problem. That query is just text. And if the app isn't careful, an attacker can write text that changes the meaning of the query itself. Let's say instead of a normal username, someone types this into the username field and leaves the password field blank or types anything. Now watch what happens when the app builds its query by just pasting that input in. Here's the key part. That extra apostrophe closes off the username string early. Then or1 equals 1 gets added as a new condition. And since 1 equals 1 is always true, the entire where clause becomes true for every single row in the table. The database doesn't see an attacker is doing something sneaky. It just sees a valid query asking for every user where this condition is true. So it returns every row. Depending on how the app is written, that can mean the attacker is logged in as the very first user in the database, which on a lot of systems happens to be an admin account. That's the entire trick. No malware, no brute force, no stolen credentials. Just a query that was never supposed to accept untrusted text as part of its structure, only as data. Bypassing a login is bad enough, but injection isn't limited to that. Depending on what the query is doing and how much access the database account has, an attacker can potentially read data they shouldn't see, customer records, emails, password hashes, modify data, change prices, grant themselves admin permissions, delete data, drop entire tables, in some configurations, even reach the underlying server. This is why SQL injection has been linked to some of the largest data breaches in history. It's not a theoretical risk, it's been actively exploited for over 20 years. And it still shows up in vulnerability scans today, mostly in older or poorly maintained applications. So how do you stop this? The good news, the fix has been well understood for a long time. The core idea is simple. Never let user input become part of the query structure. Only let it be data. Instead of pasting user input directly into the query string, the application sends the query structure and the input separately. The database knows, no matter what the user types, that input can only ever be treated as data, never as part of the command. The single quote or single quote one single quote equals single quote one single quote trick simply stops working because there's no string building for it to break out of, restricting what characters or formats are even allowed in a given field. For example, an email field should only accept things that look like email addresses. The database account the application uses should only have the permissions it actually needs. If the login system only needs to read the user's table, it shouldn't have permission to drop tables. These can catch and block obviously malicious-looking input patterns as an extra layer, but they're a backup, not a replacement for fixing the actual code. The honest takeaway, SQL injection isn't dangerous because it's clever. It's dangerous because it's preventable, and yet it keeps showing up anyway, usually because of legacy code, rushed development, or developers who never learned this in the first place. If this helped the concept finally click, hit subscribe. This is exactly the kind of deep dive NetSecVerse is about. See you in the next one.